Hello everyone. Today's topic is Bernoulli's equation and this is our last lecture of module 1. That means first order differential equation. So in my last lecture we have learned how to solve first order linear differential equation. Okay, but there are some problems. Let's take an example, or let's write the general form. Suppose we have the general form of first order linear differential equation is dy dx plus py, this is equals to q. This is the general form of first order linear differential equation in y. In y, that means here the dependent variable is y. Okay. Now suppose in this differential equation I am multiplying a factor of a dependent variable, let's say y to the power n. Okay, I am multiplying this y to the power n on right hand side. Now this form dy dx plus py equals to q y to the power n, this is called the general form of Bernoulli's equation. General form of Bernoulli's equation. Okay, so how to solve this type of equation? Remember, to solve Bernoulli's equation, first step is you cannot take any dependent variable on right hand side. I am repeating, in Bernoulli's equation, when you are solving the equation, you cannot take any dependent variable on right hand side. So obviously you have to divide by y to the power n to both sides of the equation. Yes or no? You have to divide by y to the power n. Okay, let's divide this equation by y to the power n. Dividing by y to the power n. So this will be y to the power minus n dy dx plus p y to the power 1 minus n, this is equals to q. Yes or no? Now, is this equation linear equation? Obviously not. This is not linear equation. So you must have to convert the Bernoulli's equation to linear equation. Otherwise, you cannot solve it. Okay. Now here you can see that this equation is y to the power minus n dy dx plus p y to the power 1 minus n. This is equals to q. Now if I take y to the power 1 minus n, this is equals to z. Our target is we have to convert this Bernoulli's equation to linear equation. Okay, that's why I am taking y to the power 1 minus n, this is equals to z. Okay, so let z is equals to y to the power 1 minus n. So what will be dz dx? Why I am deriving with respect to x? Because in this equation the independent variable is x, that's why I am deriving with respect to x. So dz dx equals to, the formula is n into, so 1 minus n into y to the power n minus 1, so 1 minus n minus 1. Okay, and I am deriving with respect to x, so this will be dy dx. That means you are getting 1 minus n y to the power minus n dy dx. Okay, so here you are getting that z equals to y to the power 1 minus n and dz dx equals to 1 minus n y to the power minus n dy dx. Now we have to put these values of y to the power 1 minus n and values of this y to the power minus n dy dx in this equation. Okay, so putting these values, let's say this is the equation number 2 and this original equation, this is equation number 1. Okay, so putting these values, so y to the power minus n dy dx, what is the value of y to the power minus n dy dx? Actually here, from here you are getting y to the power minus n dy dx, this is equals to 1 by 1 minus n dz dx. Yes or no? So let's put it, 1 by 1 minus n dz dx plus p into, What is y to the power 1 minus n? This is equals to z. So p into z, this is equals to q. Or you can simplify dz dx, this is equal plus dz dx plus p into 1 minus n into z, this is equals to q into 1 minus n. Now tell me, is this equation linear equation? Is this equation linear equation? Obviously yes, because here the degree of the equation is 1 and order of the equation is also 1. So this is first order linear differential equation. And what is the dependent variable? Z. So first order linear differential equation in Z. Clear? Obviously now you can solve the problem because I already have discussed this topic in our previous lecture. So tell me, what is P? Actually we denote by P, but in this case what will be the integrating factor? Directly calculate the integrating factor. So what will be the integrating factor? Integrating factor equals to e to the power integration p into 1 minus n dx. And what will be the solution? Solution is simple. Dependent variable into integrating factor. This is equals to right hand side into integrating factor dx plus c. This is the formula. Okay. So let's summarize the whole topic. First, in Bernoulli's equation, what is the general form? dy dx plus py, this is equals to q y to the power n. This is the general form in Bernoulli's equation. Okay. Number 2, what is integrating factor? Integrating factor is e to the power integration 1 minus n into p. What is n? This number, y to the power n. 1 e to the power integration 1 minus n into p. This is our integrating factor. And what is the solution? Z into integrating factor. This is equals to integration 1 minus n into q into integrating factor dx plus c. Then after solving this equation, you have to substitute the value of z. Okay, value of z means z equals to this one. Z equals to y to the power 1 minus n. Okay, so this is the formulas of Bernoulli's equation. But let me tell you frankly that actually here I have multiplied y to the power n on right hand side, but this is not necessary that always the equation will be multiplied by y to the power n. This is not necessary. Maybe there are some trigonometric function with dependent variable. There are some logarithmic function with dependent variable, anything. Actually, this is the general form of Bernoulli's equation. Okay, but this is not obvious. Okay, but just you have to remember the process. What is the process? First process is you cannot write any dependent variable term on right hand side. Okay, so obviously you have to divide by the dependent variable which is on the right hand side. Here you have y to the power n, so you have to divide by y to the power n. If there is sin y, you have to divide by sin y. If there is cos y, you have to divide by cos y. Okay, you have to divide by the dependent variable which is on the right hand side. Okay, this is the first step. Second step is you have to put z equals to the term which is attached with the value p. Here with the value p you have y to the power 1 minus n. That's why I have taken y to the power 1 minus n. Z equals to, suppose here you have p sin y. Suppose p sin y. Okay, in that case you have to take z equals to sin y. Suppose p e to the power y. In that case you have to do z equals to e to the power y. Okay, then you have to substitute these values and you will get this linear differential equation. Then the simple process, find out the integrating factor and the solution. Okay, this is the process. So let's understand this method using an example. Solve dy dx minus tan y divided by 1 plus x, this is equals to 1 plus x into e to the power x sec of y. Okay, so dy dx minus tan y by 1 plus x, this is equals to 1 plus x into e to the power x sec y. So process is simple. You cannot take any dependent variable on right hand side. Here the dependent variable is y and the term is sec y. So obviously you have to divide by sec y. So solution. Dividing by sec y. Okay, so 1 by sec y means, let me write 1 by sec y dy dx minus 1 by 1 plus x into tan y divided by sec y, this is equals to 1 plus x into e to the power x, or 1 by sec y means cos y, so cos y dy dx minus 1 by 1 plus x into tan y by sec y. Tan y means sin y by cos y. Tan y means sin y by cos y and divided by sec y. So that means this is cos of y. So cos y cancelled, you are getting sin y. Okay, so this will be sin y and this is equals to 1 plus x e to the power x. So first step is completed. Our first step was you have to divide by the dependent variable which is on the right hand side. This was the first step. Now second step, you have to substitute. Okay, so you have to take z equals to the variable which is with the term p. Here p is equals to 1 by 1 plus x. So you have to take z equals to sin y. Okay, so let z equals to sin y. So dz dx, this is equals to cos of y dy dx. Okay, actually main target is in here you have cos y dy dx na, so in place of cos y dy dx you have to write dz dx. This is the main target. That's why I am taking sin y equals to z. So dz dx equals to cos y dy dx. So let's say this is equation number 1. So equation 1 becomes, now substitute the values. Cos y dy dx, that means this is dz dx. So dz dx, this is equals to na minus 1 by 1 plus x sin y, and sin y equals to z. So this is z by 1 plus x and this is equals to 1 plus x into e to the power x. Now tell me, is this equation first order linear differential equation? Obviously yes, because order and degree both are 1. So this is first order linear differential equation in z, because here dependent variable is z. So what is integrating factor? E to the power integration minus 1 by 1 plus x dx. And what will be the integration? So this is equals to e to the power minus log of 1 plus x. Okay, and you are getting this is equals to 1 by 1 plus x. Now solution formula. So the solution is dependent variable z, so z into integrating factor, this is equals to integration right hand side means 1 plus x into e to the power x into integrating factor dx plus c, or z by 1 plus x, this is equals to, here 1 plus x is cancelled, so e to the power x dx plus c. So z by 1 plus x equals to e to the power x plus c. or you can write z equals to 1 plus x into e to the power x plus c, or z means sin y, so sin y equals to 1 plus x into e to the power x plus c, and this is the required solution. Okay, so in this way you can solve this type of Bernoulli's equation. I am writing one more question, you have to try it. Question is solve x square y cube plus 2xy dy, this is equals to dx. Okay, try to solve this question. Also, let me give you one more question, try to solve this one. Dy dx plus y by x, this is equals to y square by x square. Okay, acha, answer of first question, that will be 1 by x, this is equals to half into 1 minus y square minus c e to the power minus y square. This is the answer of first question, and answer of second question, that will be 1 by xy, this is equals to 1 by 2x square plus c. Okay, try to solve these two questions. Okay, so now our full topic of module 1 has been completed. Okay, now try to practice all the exercise question papers and your question bank problems, your previous year problems. If you have any doubt, feel free to ask me. Thank you so much.